Hey guys, this is a short video explaining how to do simple Core 1 differentiation, which is the basis of a lot of AS and A-level maths. First I'll show you how to differentiate an equation of a line, and then I'll show you a common exam style question which is applicable with all the exam boards. So the idea of differentiation at C1 is to find the gradient of a line often at a certain point. So here we've got f of x equals 5x squared plus 4x plus 2 at the coordinate 2, 4. So we differentiate that line, which I'll show you how to do in a minute, and you get 10x plus 4. Then you put your value of x from a coordinate, which is 2, into the differentiated equation, and you get 10 times by 2 plus 4 equals 20 plus 4 equals 24. So that means 24 is the gradient of the line at the coordinate 2, 4, and that's why it's useful. So to differentiate, you have to multiply the term by the power of x, and then decrease the power of x by 1. So in differentiation, you have to do it term by term. So first we'll do this equation, which is f of x equals 5x cubed plus 6x squared plus 3x plus 9. So first we'll differentiate 5x cubed. So we'll times by the power, so we'll get 5 times by the power 3, and then times by x, but decrease the power by 1, so 3 minus 1 equals 2. So here we've got 5 times by 3, 15 times by x squared equals 15x squared, and that's differentiated that part of the equation. Next we'll do 6x squared. So 6 times by the power of x, 2 times by x, but decrease the power, 2 minus 1 equals 1. So 12x to the 1, which is just the same as x. So now we need to do 3x, which is exactly the same, if it helps, as 3x to the 1. So 3 times by the power, 1, times by x to the 1 minus 1, which equals 0. And we know from indices laws that anything to the power of 0 equals 1. So here we've got 3 times by 1 equals 3. And that's another rule in differentiation. Any number times by x to the power of 1 differentiates to just give the number itself. So 5x differentiates to 5, 12x differentiates to 12, 59,651.56x differentiates to the number I just said. So yeah, basically, any number times by x to the power of 1 differentiates to just give the number itself. And finally, we need to differentiate 9, which brings me to the final rule of differentiation. A number without an x coefficient differentiates to 0. So 12 will differentiate to 0, 50 will differentiate to 0. The number I said earlier will differentiate to 0. Any number differentiates to 0 if there's no x coefficient. So 9, let's just say, differentiates to 0, so we don't need to put that in the thing. There we go. So now we collect these, and we get f dashed x, which just means a differentiated form of fx, equals 5 times by 3, 15x to the 2, 15x squared, plus 12x plus 3. And that's a differentiated form of that equation. So now I'll do an exam style question using the knowledge we've just received. Given that f of x equals 3x to the 4 plus 2x squared plus 5x plus 3, find f dashed x, the differentiated form basically, at the point 3, 4. So first we need to differentiate. So that's what fx equals. So f dashed x equals 3 times by 4, which equals 4, 8, 12, times by x to the power of 4 minus 1, x to the 3. Then, plus 2x squared, we need to differentiate that to 2 times by 2 equals 4, times by x to the power of 2 minus 1 equals 1. Then, 5x, which differentiates to 5, because, as we said earlier, any number times by the power of x to the power of 1 differentiates to just give the number itself, so plus 5. And then 3 differentiates to 0. If you want to put that, you can, but you don't really need to. So yeah, that is our differentiated form. But now we need to find the gradient at the point 3, 4. So we put our value of 3 into that, so f dashed 3 equals 12 times by 3 cubed plus 4 times by 3 to the 1 plus 5. And that equals 12 times by 3 cubed, so that's 27 times 12, which equals 324. 4 times by 3, which just equals 12, plus 5, and then you add that together, and you get 341, which is quite a big gradient. And that is a gradient at that point on this line. And that is how you do differentiation in C1. I will be making more videos, so please subscribe, and if you liked this video, please click like, and if you want any more videos, then comment and I'll do them. Thanks.